Manish, okay. Okay, we started recording. So guys, we start with the networking basics. This is the networking basic PPT. I think I already shared networking related yeah, here it is. I shared already networking basics PPT link. Okay. So I'm give you first overview what we are going to discuss. It is little lengthy topic, guys, but you don't get it much time. So because it's a requirement based on that. So actually it will take 3 to 4 days. So I will try to complete by 2 to 3 days only. I'm not going to suppress anything. Just not even I don't go too fast. But this, if you are interactive, I can complete better. So why it is taking 4 days also? People don't interact sometimes. They don't ask any question or they don't speak again. So I think they don't understand. I keep doing okay. But still, it is good. I will try to reduce few points, not points. That's drawing kind of stuff. Then we'll complete. Okay. So today is Tuesday, right? Tuesday, Wednesday. Thursday is a holiday again. So then network. Interconnection of two or more devices like this. What is network? What is networking? What is internetwork? What is internetworking? Okay, and this is a different type of networks, LAN, MAN, CAN type of networks. Okay, and what is a requirement for a network? Like what is NIC? What is MAC address? What is different medias? Means the cable kind of stuff we use in the network. Networking devices like hubs, routers, switches, modem kind of stuff, different protocols what we use in the network, and IP address kind of stuff. Okay, so that's what is NIC, what is MAC address, how to check IP address and MAC address. Okay, and what is the different type of cables we use it, like a coaxial cable, twisted pair cable, and a fiber optical cables. Okay, and also we're going to discuss how hub is function, switches, routers, and a modem, and a ping and a trace are the commands, and physical topology is also there. So what bus topology, ring topology, mesh topology, star topology, tree topology, this kind of stuff. And also we'll discuss OSA layer is there, but this is a little order is changed in the PPT. So no problem, even like just I'm telling Vauri, right, what we are going to learn, not in order. Okay, about IP address and IPv4, IPv6. Okay, not depth of IPv6, just 1 or 2 points in IPv6 only. IPv4 classes, their subnet mask, and private IP address, OSA layers, what are the several layers, and protocols and their port numbers, each layer explanation, and that's the point, TCP IP. So troubleshooting using a OSA layer if time is permitted. These are the things we are going to learn in networking. The first one is, guys, network. Definitions are there. So first we will take that one only. Okay. So to complete faster, I can directly use this kind of stuff, like what we can say. Direct PPT is enough. Like if I go through the PPT, so simply I can able to explain. Okay, so it won't take much time, but if I put it in a notes, it is very easy to read from the notes. That's why I keep it in everything in a notes. Okay, we'll see. Guys, interconnection of two or more devices is called a network. And the communication between two or more interconnected devices is called a networking. What is internetwork? Internetwork is a connection of two or more networks. Internetworking means communication between different networks. Okay, so I will try to use even time taking process only, but still it's better to write and draw here only. So I have a devices. Have a devices. These devices are connected in the network. So network like that is symbolically can show you different ways, but I am showing in a simple like a device is connected to a switch kind of stuff. I am trying to show you. These devices are connected to the proper device like this. So I put a this name is PCA, PCB, PCB. What happens? C is become bigger. Okay. This is the device, just for our understanding, guys. Simple network it is. You can use as this device either it is hub or a switch. You can use hub or a switch to connect a device. So then I created a network. So for me it is a simple network. Okay, so this is network. So I am changing my these names also. Okay, so this is a network. Now this is a network. Now if A is communicating to B, A is communicating to B. Okay, A to B communication is there. Means it is a inter networking. Of course, it will communicate like this, so that's why I'll put it. So it is A is communicating to B, so it means networking. Communication between interconnected devices called a networking. Same kind of thing I'm going to take like this. Okay, I'm creating another network. For example, you have a two networks or two or more networks. Okay, I have a two networks or two or more networks. Okay. Another network. It's not like a some not the same LAN network. Simply think like logically and physically it is different network. And we are connecting these devices together. Okay, so same thing. If A2 can able to communicate it to B2, then it is networking. Now it is network. Networking means communication. Network means connection. Very simple to get it. Okay, now if you are connecting these networks and make them communicate, so that is a internetwork. How I'm connecting this internetwork kind of stuff? Look at here. So router is a internetworking device. Router is a internetworking device. It means you want to connect these networks. You need a internetworking. This is one network. This is another network. We are connecting this network like this. It means internetworking. Okay. The next one is so communication. For example, PCC1 is want to communicate A1. A1, A2. A2 is in different network. C1 is in that different network. So I'm communicating like I went to this, then router, and I will go outside of router, reach another, and finally reach here. Finally, reach. This is always gives. Yeah, what happened to this? C1 to our switcher hub to this router like this, then this router to this router to this switch to this router. That is there. Okay, this is internetworking, communication between different networks. There are logically and as well as a physically different networks. So guys, this is a one network. Okay, this is difference. This is a network. This is a network, and I made a connecting these networks means it is an internetwork, and make a communication between these networks. Simple to remember, guys. The router is internetworking device. Not internetwork device. It is internetworking device. Okay, which make a connecting different network. Hub and switches for a single network. To create a single network, it is a single network. Single network hub and switches we use in a single network. But if there is a multiple networks, you want to connect up multiple networks. You need to connect and communicate different network, not two networks, different networks. Use router to create a single network hub and switches to communicate or to connect and communicate different networks, we use a routers and switches. Why this text is showing very small size? Okay. Guys, understand this part? Network,
Yes, sir.
internetworking. Okay.
Yes, sir.
Yes, sir.
So the same thing, I use only single router. Like this is different router, this is different network, this is network. So I am communicating between these networks through the single router like this. So both are correct in a different ways. Generally, guys, we have we should in my VPT I have a type of networks, but I will start with anyway. I start with the network part, then I will go to the connectivity. Okay, okay, topologies. Okay, so we have a two type of topologies, guys. We are connecting devices. We connected a devices. Without connecting, there is no network. Without network, there is a no. Without a network, without connectivity, we don't get any network. Without a connect network, we don't get a networking. Okay. So network. Okay. What is the physical topology? The way of devices we are connected physically. How we connected a devices. Based on that, we call it as a physical network. Our network. Logical topology. Logical topology is the based on the how IP address is configured. Logical topology is based on how IP address is configured. So logical topologies will be created. So we are discussing about the physical topologies. First of all, we are discussing about the physical topologies. The topology in a physical layout of system connected in a physical network are the way of connecting devices, way of the device is connected or connecting is a physical topologies. The different physical topologies are there. Some physical topologies are a bus topology, ring topology, mesh topology, star topology, and hybrid topologies. These topologies are again came from a different point of things. Okay, point to point, multi-point topology, and tree topology. Recently, people are keep chanting about a tree topology. That's why I'm adding that tree topology also. Okay, yeah. Actually, paintbrush is the best one to draw everything. So we'll see. So one by one topology, we'll see. This is a one device. One. I think four is enough. This one. There is a backbone wire, and devices are connecting to this backbone wire only. So we have a devices. For example, this device name is A, B, C, D. So these are all devices are connecting to this backbone wire only, and data is transmitting through this backbone wire only. This is called a bus topology. Okay, what is a bus topology? All the devices are connected to a backbone wire. It is very easy to configure. Okay, easy to configure. It's simple configuration only. But there is a problem. If in case if this backbone wire is down, so communication will stop. If in case if backbone wire somewhere there is a cutting is happen like this. Okay, some disconnection is happened in the backbone wire. So further communication will stop. AB won't communicate CD. Okay, so that is the thing. It's so difficult to troubleshoot. Okay, this bus topology we used earlier. Okay, in a cable TV type. So cable guy run a cable to home. Okay, there is a main cable. So we are all connecting to that cable only. That is a bus topology. One device is connected to another device, and that device is connected to another device. Okay, that device is connected to another device. This is want to listen to me. It's okay. And that is connected to like A is connected to B, B is connected to C, C is connected to D, D is connected to A. Means the last device is connected to the first device. Yeah, not in order, like I will put it in order otherwise. Whether they should hear in the one order. Okay. Normally we see the devices are connected in a ring topology. So no problem. There is a connectivity. You can see the connection. Okay. So it is form a ring like this. Means first device is connected second, second connected to third, third connected to fourth. Like that, last device is connected to the first device. It create a one ring, and these devices will communicate each other. These devices will communicate each other. Okay, but they won't communicate each other. Sorry. If A want to send a message to D, A, B, C, D, how it is reaches. D want to send a message to A, D, E, A. Means the devices will communicate either in a clockwise or anti-clockwise. It's good one direction only. They will communicate devices using a protocol, algorithm. Okay, it is easy to configure, but still difficult to scaling. Means you can't add a extra device. If you add extra device, additional. If you add a extra device, you have to configure additionally. For example, you got a new device like this. What to do? Again, you have to connect here to here And again, you have to configure again for every device. You have to configure how they should communicate each other. Okay, so that is the thing. Next one is if any device is down, for example, C is down, A to D communication. A send a packet to B, but B cannot send a packet to D. Or if this particular wire is down, wire is not working, wire is disconnected. So what happened? A cannot able to send a message to C. But C to B communication is there, but B to C communication is there. It's a little difficult to troubleshoot, difficult to scale, and it works based on an algorithm. But to avoid this unidirection means either clock or anti-clockwise direction. So we can put a two wires instead of one connectivity, two connectivity between the devices. So then one line it works with a clockwise communication, another one is anti-clockwise means A want to send a message to D, A, E, D directly. E want to send a message to A, D, E, A using a double ring topology. Two paths we are giving. This is a ring topology, guys. How it is look like. First one is one device is connected to another device. Other device is connected to another device like a. So finally last device is connected to first device. Bus topology, ring topology. Sorry, first of all, we have a device names, right? A, B, C, D. Now, if anybody can able to guess, can try guessing.
Every device is interconnected to each other, sir.
Very good. Every device is connected to all other devices. Which topology it is?
Star.
Star topology or a mesh
Yes.
topology. Mesh topology. Okay. So just for easy purpose, people draw first star for making a more easy to understand. People draw a star. Okay. And they forget which topology they are doing. They will tell like a this is a star topology. In our mind is also when you see a star first, we think it is a star topology. It is not a star topology, guys. It is a mesh topology. What is a mesh topology? Every device is connected to all other devices. All other devices. Actually, I will draw properly, but because of these dots are controlling me. Like if you want to connect here, I want to connect from here, but it is directing me to like that. So just instead of wasting time on fighting with that one, I try to like this is good drawing actually. It is. Don't listen to me. It's like this. This also. This is good. This is the mesh topology. Here it is very complex. Okay, complex. See how many wiring we have used. Every device is connected to all other devices, and it is a complex connectivity. Okay, next one is mm, what we can say. Um, it is difficult to troubleshoot, and it is reliable. Why it is reliable compared to bus and ring? See, if B device is down, but remaining devices will communicate. Communication don't stop. Only B device is out of, but remaining A, C, B, D, E will communicate each other. For example, this Butler wire is down. Only B to E, E to B direct communication is not there. But A to E, A to B, A to D, A to C, C to D, this communication is there. And B to D, B to A, B to C, like that. Communication is there. Only direct B to E communication is not there. Remaining devices will communicate. It is a redundant, means one device or one line is down, still communication will be goes on. So we don't use the mesh topologies in a regular network, guys, but mesh topologies are using. Even people don't use bus topology, ring topology in general nowadays, but mesh topology is still using, but not in the regular LAN communication. We use a mesh topology in the server rooms, storage kind of stuff like a SAN type of storages in their networks. Okay, and
Sir,
servers, core routers use a mesh topology. Yeah, tell me.
sir, which topology is commonly used in office?
Star topology.
Okay, sir.
Okay, good. So mesh topology. So we are using mesh topology only in a certain places only in a certain organizations. Servers, you have a 10 servers and you are connecting them as like a mesh plus star, both they will connect. Okay, or and if you take SAN type of storage, like a SAN storage having storage devices plus storage servers, storage switches, means fiber optical switches are there. They'll create in a mesh because of one wire or one line or maybe one device is disconnected, no problem. Other through other devices they will communicate. It is a reliable, okay, but not using in a regular manner. Why? Because it is a complex, difficult to troubleshoot, difficult to scaling. That is difficult to scaling. If you put a one more device, what happen? Again, you have to go to each and every device. You have to insert a one more NIC, means for connectivity NIC, and you have to connect it. So that is become more complex than a normal. Okay, so that is a mesh topology. So in this topology, guys, we use a centralized device, and the devices are directly connected to this centralized device only. I have a APC, for example, there is a device A, B, C, D, and E. So this is, we can use either hub or a switch. So we are connecting this hub array switch device directly. So we have a connecting to this hub array switch. Every device is connected to hub and switches only. So we are all communicating, like AB communicating to the switch. If A want to send a packet to B, so it will send it to this switch only. Okay, so this is actually star topology. Okay, this is the star topology. Okay, it is a very complex, but it is very simple. Now, okay, but redundancy is not there. But still, you can see, guys, if B is down, no problem. Remaining devices will communicate each other. If B device is down, the remaining devices will communicate each other. For example, this wire is down, no problem. Remaining devices will communicate each other. Means main other communication won't stop, not a dependent. But this switcher hub is down, entire communication is down. It is simple to configure, little costly. Why? Because we are using additional device to get connected. Little cost. Why? Because of additional device. But it is very simple and it is a scalable. Scalability is there. Okay. Scalability. What is the scalability? Ability to increase the scalability. Scalability means ability to increase, and it is easy to troubleshoot. Not reliable as mesh topology, but still easy to configure, easy to troubleshoot, and easy to scale. For example, I have a new requirement. Sorry. Okay, I got a new more devices are there. So what I will do? Okay, so I will add these devices. I want to communicate, but my switch is having a limited ports. So what I will do? So I will add more devices to it. Okay. So I can give other name E, F, G, H, I, J. Any name we can put it just for our understanding only. Okay, this is another network. So what we can able to do? So I connected a network here from here. Just connect these two devices. Okay, both are same logical part of network. Both are same network space, same LAN connectivity. So I am giving a LAN kind of stuff. Okay, so I connect this one switch to another switch. So then multiple devices, large number of devices, we can connect it. So this is the star topology. This is a star topology. So main important topologies are completed, guys. Bus topology, ring topology, mesh topology, and the star topologies. Anything remaining is there not point to point topology. So I don't get much space in down. I can get it, but I have to keep drag this to down. Two more topologies are important topologies. These are the main topologies, guys. I can put it side, but it will give confusion.
Sir,
You tell me.
sir, where is the main server in these topologies?
So we didn't put any server kind of stuff here.
Okay.
that is enough. So here, if in case, very good. For example, I want to, this is ABCD are not a computer. It's like we can think like a device. It can be a server, it can be a normal desktop, it can be a printer, like that. The device which can able to connect a network. So that's the point. Okay. So which one is server? So in this any place you can put a server directly. Okay. So it does not mean without a server it won't work. That kind of stuff is not there here. Okay.
Okay, sir.
Next one is just I am telling point to point. Okay. For example, this is a device and this is device. Every connection is point to point connection only, guys. By generally. Okay. Every connectivity is a point to point connectivity only. Okay. Point to point only. Okay. So in generally, the routers are either connecting in a point to point manner or a point to multi-point manner also. So for example, you take the router connecting like this, either through WAN link or a normal LAN link. Just I'm giving point to point. Similar devices, when you connect, you must use a this type of key. This is also a point to point. You know, multi-point. This is a switch is connected to other devices. It's a point to multi-point connectivity. Okay, this is also point to multi-point switch is connected to other devices. That is a point to multi-point connectivity. And I'm trying to show you some other point to multi-point connectivity. Point to multi-point connectivity. Okay. This work is completed. Only thing is I have to add point to point. This is point to multi-point. See? Yeah, very good. That's why it is not giving a space to do all these things. Even I make it very small also, it is not giving. All our work is done, we are damaged. From here it is completely wasted. I want to save time, but it is. It is showing the grid border. Should not cross that border. Guys, understand bus topology, ring topology, mesh topology, star topology.
Yes, sir.
Yes, sir.
Yes, sir.
Just I am redrawing because I can give direct pictures, but if we draw, then we'll get a understand. Okay. So this is my switch hub centralized device. It can be, we can use any of the devices which are a hub. Okay, so this is a some device, either it can be a server or it can be a normal regular desktop system. We are all connecting to this hub or a switch. So this is star topology. So it is, which is we are saying is a so if you add one star topology to another star topology, means both are separate segments. That's the name is there. That's for that one. There is a name called a segment. Okay, this is one segment. This is another segment. Okay, when you add two segments directly in the LAN, not the router connectivity as like as before I showed. Okay, you're connecting like this, whatever how it is a again it becomes single segment only. Okay, G H. This is one segment, this is another segment. Both are star topologies, and I am connecting these star together. Okay, so this is called a extended star topology. So this is, we call it as a extended star topology, because star topology is a scalable, multiple number of devices you can able to add in the star topology. That's the point. And here it is, I want to say, show you, that is point to point. and we won't get much place here. The point to point means the switch to PC we are connected, so that is also called as a point to point. Okay, two devices are connected directly, that is a point to point. So another example, our routers are connected to point to point. Better to resize these things. uh, so totally a 10 minutes class become a half an hour class. So this is point to point. Point to multi-point. Means one device is connecting to multiple devices. Okay, the switch is connecting to the multiple devices, means point to multi-point. Switch connected to a PC, point to point means everything is a point to point only, guys. Okay, but sometimes point to multi-point means one device is connected to multiple devices, or multiple devices are connected to a centralized devices. This is point to point, point to multi-point. One more is there, that is called a tree topology. Okay. In the PPT, you have an explanation about each and everything except tree topology. The tree topology is actually there is a backbone wire. It is like a hybrid topology type only. There is a backbone cable and different networks. They are connecting this to this backbone wire only. Okay, so this is what I am trying to say about a point-to-point each and every topology. Bus topology, mesh topology, ring topology, star topology, and a tree topology. Got the point, guys?
Yes, sir.
Yes, sir.
Just I will tell about these type of networks, then we'll take a break. Okay, then we will discuss the many things. What are the different type of networks? We have seen what is network. Okay, so what is networking, what is internetwork, how they are connected. Next, depends upon the geographical range. What are the topology and all depends upon the geographical range. We are telling what type of network it is. Depends upon the geographical range or a size. We are putting a type of networks. One is LAN network, local area network, campus area network, metropolitan area network, wide area network, and personal area network, and home area network, and storage area network, like so many other area networks are there. But very important is these four are very important. From starting, these are there. These are later added. Okay. So local area network is simple to understand. Of course, I don't draw now. Okay. So because it's the drawing is. I have a simple room. So in general textbook definition, I'm telling guys. Okay, in a single room, you have a 10 devices are connected. So then you created a simple LAN network. Maybe entire floor you have a devices and you are connected and you created a simple LAN network. Maybe entire building you have a multiple devices and you connected together and you created a LAN network. So your LAN geographical range is from single room to entire building is comes under single LAN network. Campus area network. Campus means university campus, college campus, companies are there. No? For example, Tech Mahindra. Have seen Tech Mahindra campus. That's why I tell example. Tech Mahindra campus, Cognizant campus, TCS campus. So the multiple buildings. Campus means it multiple buildings are belongs to one organization or one entity, right? So in a college or university campus, you have a different departments, administrative department, your ECE department, mechanical department, CSC department, management department, science related department, arts related departments are there, commerce related departments. You take university having so many other departments. Think like each department is a building, so your entire building one LAN connectivity and you connect all these LANs together and make it as a simple big LAN connection. But it is not a big LAN, it is also called as campus area network within the campus. Within the campus, we are able to communicate within the campus. Metropolitan area network. Metropolitan area network. You take a city. Okay. 5 minutes. 5 minutes. I will get 5 minutes. 5 minutes. Metropolitan area network. What is a metropolitan area network? You have a city, take a city and city having so many people, so many buildings, so many different department. I didn't written any department. The diagram is also wrong because I pointed to you one place. But actually guys, these different departments are connected each other and they can able to communicate. Not only departments, people in the city also, their networks also connected, but it has become a very large network, but within the city only. Within the city, people can able to communicate. For example, I need to get some hospital report from the police station, then I will get it. Okay, so every people will maintain a servers data, simple centralized data in the city, so people can easily can get a information from it. So that is a metropolitan area network. Wide area network, it is a global range, guys. Not a room, not a building, not a campus, not a city. It is a worldwide wide area network, not worldwide area network. It is wide area network. Means entire globally from any point to another point we can able to communicate. The network size is so totally global it is. So that is a LAN WAN CAN kind of network. So campus area network, metropolitan area network. Of course, PAN and HAN is also there. So that is also I will tell before going to that. So yeah. Personal area network, guys. Personal area network means a person, one person is there. Okay, he has a devices like a smart mobile phone, smart watches, okay, smart rings, smart shoes. So he is having his own personal network. It is that is a personal area network connecting his personal devices together. So it is a personal area network. Including nowadays you can connect it to bike, scooties, bikes. Okay, that technology also became. And home area network, it is a home automation related. Nowadays we got smart TV, smart LED, smart home appliances, and we can control them through the smart plugs also came, smart washing machines. Okay, so like that it is a you can control them with Alexa or Google Home Next kind of stuff. We can connect it and we can use with the voice commands. Okay, we can connect all this together and control from centrally. That is home area network. And another one is storage area network. Storage area network actually not comes in the this part, guys. It is not even an area network. Storage area network comes under storage solutions. Storage solutions. They use these things in the enterprises, means big organizations only. They use SAN storage solutions. Again, guys, what is LAN? Local area network. It is a local network. Your private network it is. Okay. And CAN, campus area network. Within the campus, you can able to communicate. MAN, metropolitan area network within the city. WAN, it is a global network. So it is a networks of network. It is mostly we are in the public network also. You say public. There's two terminologies are there. One more I am adding because one guy is asking me this question. Extranet. I'm adding, but I'm not want to tell. I don't want to tell extranet part. Intranet, internet. Intranet, internet. So what is intranet? So when you want to communicate within the LAN, okay, my server is in my LAN communication only. Yeah, I will tell intranet and internet later, guys. So this is I will tell. From here I will tell, and again we'll going to discuss after break. Okay, about this kind of stuff plus NIC media. These are all going to discuss. Okay, so just take a break. So I will because drawing is there again. It will take time. Otherwise, I will tell you orally also, but take your time. Okay, take a break, come back in a 4:40 is enough. 15 minutes. Have a tea or coffee. Please don't sleep.